Yo, what's up guys? iReapism here, and welcome back to another video guys. Today, I want to briefly explain the progress on a new program I am making. It's a password generator, or more specifically, a manager. So I'll have capabilities of generated passwords, so essentially, I'll be embedding my previous program, the random string generator, within this in some way. Either I actually implement the actual framework of my program, or just some classes that describe the random string generator. Whatever it is, it will embody it somehow. So, this might seem strange to you in the context of me making this type of video. I'm usually known for gaming videos, but on my old channel, over the years, I've showcased a few programs that I've made. And basically, I'm going to just carry that out on this channel. So, let's see what you guys think. I want to kind of get you in the mindset of how I'm making this program and what kind of variables I need to take into account. So it's really interesting. It's something that you can follow with yourself, and it's really helpful when you do it. So let's open up the file. So right now I have a really interesting kind of splash screen right there where it has like this gold lock that from gray turns gold. So that basically shows the progress of it loading. And then I have a setup wizard, a first time opening. So I'll read it as it's written right now. All of this is subject to change in some way, shape, or form, such as the text and possibly what kind of information to display. But let's just read it how it is, and I'll walk you through it. So it looks like it's your first time opening the application. Welcome and let's get started. You'll be asked to browse for a text file on your computer, or you can provide a direct URL to the text file to read the info. Reap's password manager safely loads the text file encrypted until a series of exercises you set are completed to decrypt it. It contains a lot of space for storing the domain service, username, email, password pins, security questions, and other stuff regarding one account. So that's probably something I'll add later, but I wanted to clarify that is that there's a lot of space for it to store one account info, like lots of stuff, like a pin, a password, email, and username. That's a lot, right? It's a lot. So we go ahead, press next. Please enter your username and account name. Your password will be a series of steps to solve. The account name is giving your text file name. So anything, basically anything. It can be anything, right? It doesn't matter. So I'll just do reap. So now here we browse for a text file. You'll be able to pull the text file, which looks like this. This is a template. And basically, this is the template. This is the format you follow. You can write the account service name here. Separate it with an ampersand. Whose account? Separate with an ampersand. So like, here's an example. Email, username, password, pin, other. So Google account, Anthony, it's for me. Example@example.com, example user, example password, 1111. That's the pin. And other, this can be additional information such as security questions or other questions that some of these websites require you to do, like a phone number, for example, that you use to two-step verification on the account, whatever you need. Now I wrote something here that is subject to change probably, but it was just my ignorance, I guess, of making this program. But I'll essentially kind of give you the background. So let's read it actually together. Please note, it is absolutely recommended, I'm not forcing anyone to do this, recommended that you do not enter the full emails or usernames or passwords, not and, in the text file in case your account becomes compromised. And when I say account becomes compromised, not that account that you stored, but this account, this password manager itself, right? Because if you think about it, which I'll get to later, it's really bad. So I recommend you put up to a maximum of 30% of the characters that make up either your emails, usernames, and passwords, etc. It just takes someone to compromise your password manager account to get all your accounts. And it sounds exactly as it is. If someone, perhaps, very extremely unlikely, that someone gets onto your password manager account that you're making right now, they have all the information to your accounts. So basically what I mean is for them to use this, it's only a local based setup. So that means it doesn't use the internet or anything. It doesn't store anything on the cloud or anything. It's completely local. So if someone's at your house and they, find a way just somehow to get through your account, well, they have all of your information. It's not like you have whatever you put in there, right? It can be your bank account information, your Amazon. We're talking about websites they use on a daily basis, your YouTube, etc. All of it can be compromised. And this does not go for my password manager only. I recommend you do this with every password manager. Now, this is the biggest problem that many of you will probably see with what I'm saying, is that the purpose, the essence of a password manager is to prevent this, right? But this is just a recommended extra step of security. So in case it does happen, they can't get into your account, which is the beauty of it. That would actually leave no way to get into someone's account after doing all of this, right? In order to crack this account, you essentially need to do some insane levels of hacking, right? And I'll show you why. But basically, if it does happen, essentially, that's what it is. It's just a recommendation. You don't have to do it. For me, I'm gonna do it because my passwords are embedded into my soul, essentially, so I don't need to have any other reminder other than a few characters to just specify which one I'm talking about. And now, how to secure your account. Now, typically, passwords are used to secure accounts, but I write here, not recommended. Why? All you need is that password to just brute force, which probably is unlikely anyways, or a dictionary attack, or a rainbow table, or all the above attack, right? Whatever. Once you get that password, that's it. Your account becomes compromised. But special key and pattern lock offer another layer of security over these high value passwords. So, for example, a pattern lock can look like this. And then I create a pattern like this, just any shape. And this particular array yields 33.6 million combinations. So, not a lot. Definitely very bad, actually, the way it is right now. A computer can brute force all of this, like within a second, easily. Brute force all of the iterations of this, all 33.6 million, by the way. Not let alone let it brute force through a few thousand and get to your pattern lock. But brute force through all of it can be done within a second. Even on my computer, it can be done less than a second, depending on how efficient my algorithm is, assuming it's very efficient. So, with that being said, there's extra layers of security. For example, increasing the grid, which I will be working on soon. But basically, you'll be able to do this and increase this grid. And basically, that exponentially increases the combinations, which the only way to crack this, really, technically, is brute forcing. You could, do something clever where, let's say, for example, a lot of humans in error make for their pattern locks to be representations of letters. Like that would be an A, I guess. Or it can be very simple, like that's an A or that, right? Whatever you want. And it'll brute force these simple patterns of representations of letters. What you want your pattern lock to be is something absolutely unrepresentable. It doesn't look like anything. You just remember it like that. What does that look like to you? Well, it could be a person, bent over in a very interesting way. Definitely not in a feasible way. Doesn't look possible the way this person's bent. Or it could be a twisted eye. Anyways, whatever it is. It's not necessarily recognizable, and you want to make your pattern lock just this way. So it's at the very center of being only able to be obtained through brute force, which is what you want all of your data that you want to secure to be. You want hackers, the only viable way is to brute force. And viable it is that it takes millions of years for some, algorithms to actually brute force through. So enough with the, all this technical stuff. let's start developing some code, or not really code, pseudocode. Alright guys, so what I mean by pseudocode is just as simple as it sounds, like create representations of code. So, essentially, I want to not really create code that I'm going to use for the program, but like some ideas and try to represent it with pseudocode that I have for this program, an extra layer of security, because, like I said, I need to develop this program to be 100%. This program has to be 100% fail-proof. To my knowledge, obviously, there's always breaches and other websites get leaked, all this stuff, account information gets leaked. But to your best of knowledge, to your best of trying to break it yourself, it becomes unbreakable. You want to always yield to that high expectation when you make something like this. So basically, my thought process is, if you were to develop some of these types of things, the type of things you want to do, like for example in the pattern lock, is not leave it 5x5, because basically 5x5, it's represented this way. Let me show you. 5x5 grid, this 5x5 grid, either can be white or black. Black meaning it's selected. It's true or false, let's say. And there's two states. There's on and off. And there's 25 different boxes, so it's 2 to 25. And that equals 33.6 million, right? Now, I want to have a maximum threshold of 50 by 50. So that will be 2 to the 2500 power, right? And that, if I remember from my notes today, here, I actually have it right next to me. Let me grab it. That is equal to roughly 3.76 times 10 to the 752 power. Now, brute forcing that is just impossible. You can't. There's not enough time in the universe to brute force something like that. Put all the computers ever made, all into the future of humanity, till the future, at the rate using Moore's law, which is the rate of how fast computers are being made and stuff like that. Take all of the computers that'll ever be made, let's just fit them in a universe, right? Hypothetically, put all their computing power together and use the estimated age of the universe, the life of the universe, lifetime, which is like 10 to the 100, right? Use that as a lifetime for this brand new universe being born till this time, and years, whatever, and you will not even come close, not even to a factor of solving it. So this is the upper bound. Just a 50 by 50 grid is what I'm talking about. So a 50 by 50 pattern grid where you draw a picture. This is how many combinations of that that you can make, how many pattern locks you can make out of that 50 by 50 grid. This obviously is an example of a 5 by 5 grid. Now 50 by 50 is literally 10 times larger. So this is definitely something to think about. So you definitely want to, again, like I said, when you use a human-based pattern, pattern locks, like where a lot of people like to draw letters and stuff, if you do that with this, it will be cracked within a millisecond, because if you draw a perfect M, right? And let's pretend this is a 50 by 50 grid. And basically, it would be a substitute for dictionary attack, right? This would be the same method used for dictionary attack. Basically, let's say, this is not an M. This is absolutely not an M. But let's say if it was, right? How would we draw it? Let's say that's the M. I make that on my 50 by 50 grid. It gets cracked instantly because it's in this like predefined rule set of what to check. Or this M. I'll check all of this, like bolded M, whatever you want to call it, like that. Large M. And then M's with, just random, whatever, black squares attached to it, for example. It'll do lines, H, for example, H like this with a plus. Like, it'll do all of these before it starts doing any complicated, random, non-representable pattern like this, for example, like I did before. You just want to represent something. Like, just, it's not It doesn't make any sense really what it is. Like that, something like this. Just so weird, like that. Just it doesn't represent anything, no character, right? As best as you make this pattern not represent anything, and you can remember it, it becomes the more secure pattern. So, like I said, that's really interesting and something to take in consideration. So that's when, basically what this stems from is I have to find a way to get the user to make the most secure, basically, password or authentication, basically, any one of these, most secure way using these large values. And for example, the password can be 6 characters, right? Something stupid, right? 6 characters, by the way, not very smart for a password. That can be brute forced within seconds of any regular computer. But let's say we do it. Now let's clear this. So let's say I want a password that's 6 characters long, and my character list is all uppercase and lowercase letters. That's 52. So 26 times 2. That's 52, right? Like this. And then plus the 10 numbers, so that's 62. And then a length 6. That is our number of ways to arrange that string. And you can see this in my string generator. But let's just use this as an example. Instead of encrypting it back to 6 letters, right, of unintelligible data, which could be secure, you can still brute force 62 to 6. So something clever to do is encrypt this with something like a 1024-bit string. I don't have the exact names of what they're called, but I know Google, I think I remember reading about this, uses a 2048-bit hash that represents your password. So that means the number is 2048 bits, so 2 to the 2048, something like that. Like a large number, right? Way larger than anything I've showed you before, right? So you're basically safe, depending on, leaks and stuff like that. But yeah, guys, this is the whole premise. I want to design and I want to show you guys how I'm going to design making less secure things more secure with just some basic knowledge of computing. So thanks for watching, guys, and let me know if you guys enjoyed this video, and peace out now.